this video, we're going to look at solving equations that involve trigonometric functions. We try and solve these just like we solve other equations to isolate our unknown. So we're going to have equations involving an x, and we're just going to try and get the x by itself so we can figure out what x must equal for the equation to be valid. So it's called Solving Trig Equations 1 this video, as there are 5 such videos in this series. So as we go through those videos, the problems we look at will get harder. We're going to start off with some relatively simple ones for this video. So example, solve the following equations. We've got a sine x equals 1/2, where x is between 0 and 360, and b cos x equals -1/2. Here it tells us answer in radians, so we can assume with the first one we're answering in degrees because the range for x is clearly given in degrees. But with the second one we're told to answer in radians. So let's have a look at a. So how do we solve a? Well, we could start by rearranging. We get that x equals inverse sine of 1/2. So straight away we can get, if we put that into a calculator, or you might just know what inverse sine of 1/2 is. If not, put it into a calculator and the calculator would tell you it's 30 degrees. But the thing is, if we ignore the range we're given from 0 to 360, in general there's an infinite amount of values we could put into sine and we'd get 1/2 for sine of x, because a sine, if you know the graph of sine or cos, they're a wave. They make a wave that goes on forever in both directions. The wave just repeats over and over again, so we could get many values that would give us 1/2 when we put into sine, but the calculator always just gives you the one closest to 0. So to kind of understand what we're talking about here, let's have a look at the graph of sine. So the graph of sine looks like this. This is just a part of it. This is the bit from 0 to 360. It's a wave, and over this period from 0 to 360 it starts at 0, it goes up, down, and gets back to 0. If we continued this graph beyond 360, it would then just do the same thing over and over again. So from 360 to 720 it would do the same thing, and then the same thing again. And the same if we went in the negative direction, it would do the same thing. So hence, if we pick anywhere on the y-axis from -1 to 1, and we drew a line, it would cut this graph over and over again, so there'd be an infinite number of values on the x-axis that would be giving us that value for sine of x. And if we do that for our value, which is 1/2, we can see that we're only concerned about this range from 0 to 360 because it's given in the question. But in this range, it looks like there are 2 answers that give us sine of 1/2. We can see that this line is cutting the graph twice. Now we've already found the first one, that's 30. Now we have to figure out what the other one must be, and that's not so hard to do, because the good thing about sine waves and cos waves is they're very symmetrical. So if we look at just the first half here from 0 to 180, this peak, it's symmetrical about that 90-degree line in the middle. So if we've come up 30 from 0 to find our first solution, this second solution must be 30 down from 180, i.e. it's 180 minus 30. That's the solution here, because it's in the same position as the other one, just on the other side. So if it's 180 minus 30, it's 150. So we can write that up here. X is either 30, that's from our calculator, or it's 180 minus 30, which is 150. And in the specified range, 0 to 360, that's the only answers, so we're done. So let's try B. Now B is a little bit trickier because we're not given a specified range. We're told just find all solutions. We assume if there's no specified range, then we want all solutions x such that cos of x is -1/2. And as I just said, there's going to be an infinite amount of those, so we're going to have to find what they are and then find a clever way of writing them down so that we don't have to write an infinite amount of things. So we do the same thing, we rearrange, we get x is inverse cos of -1/2. Now if you put that into a calculator, it'll tell you that it's 120. So cos of 120 equals -1/2. But we're told to answer in radians, so let's just convert this by timesing it by pi over 180, which is something we did in the conversion videos in this series. And that tells us that it's 2 pi over 3 if we simplify. So we get 2 pi over 3 radians, okay? Now we do a similar thing. Let's take a graph of cos. I'm going to take a slightly larger one, so we're going to see more of the cos wave than we did of the sine wave. So cos is a little different, it's just shifted slightly compared to sine. So you can see it starts at 1 when x is 0, and then over the same range 0 to 2 pi, so that's the same as 0 to 360, but we're showing it in radians because we have to give our answers in radians. It does one full wave and then it just repeats. So you can see if we go down from 0, it does the same shape, and if we continued this graph in either direction, it would just do the same thing over and over again. So if we put a line down at -1/2, we can see on the bit we've drawn there are 4 values on the x-axis that give us -1/2 when we take the cos of them. You know, just in what we've drawn there are 4 answers, but this graph goes on forever, so we'd actually keep getting more and more answers. So let's have a look at, well, there's 2 pi over 3, that's the answer that our calculator gave us. And what you always want to do for any problem like this, whether you're given a range to find answers in or not given a range, you first look for answers, whether it's sine or cos, you look for answers from 0 to 2 pi. Because over that range, the graph is doing something different. It's doing this wave, and then in each, as you extend the range either way, it just then does the same thing. So you find all the unique answers that exist from 0 to 2 pi or 0 to 360, and then you can calculate what all the other answers must be relative to that. So if that sounds a bit confusing, we'll do it now and you'll see what I mean. So we found one answer in that range, 2 pi over 3, and we can see that there is another answer here. And just like last time in A, we know that this graph is symmetrical about that pi point on the x-axis. So the distance that this solution is from pi is pi over 3. So we've got 2/3 pi, 2 pi over 3. If we add pi over 3, we'll get 3/3 pi, that'll take us to pi. So we need to go pi over 3 up from pi, so we do pi plus pi over 3, and that's 4 pi over 3. So we found 2 solutions in this range, and they are the only 2 solutions in the range 0 to 2 pi. But we can see, just some looking, that there are more solutions. So I'm going to write down up here that we've got x equals 4 pi over 3 is another solution. But we can see that there's more. What about these 2 down here? So let's look now down in the negative x region. Well, because it's symmetrical, once again, we can see just by looking that these are -2 pi over 3 and -4 pi over 3. Now, what's generally always true with cos or sine is because they have a period of 2 pi or 360, that is, they repeat every 2 pi or 360, that once you find one solution to an equation like this, you know that if you add or subtract 360, well, we're working radians, so if you add or subtract 2 pi or any amount of 2 pi, so 2 pi or 4 pi or 6 pi, then you're going to get another solution. So we can see that here. Say if we take our solution 2 pi over 3, if we go down 2 pi from there, we would get to -4 pi over 3. So if you subtract 2 pi from 2 pi over 3, you get -4 pi over 3. And if we subtracted another lot of 2 pi, we'd get another solution. So once we found all the solutions in what's called our principal range, so from 0 to 2 pi, we can add or subtract any multiple of 2 pi onto them to get another solution. And because we're not given a specified range for our solutions, we have to include all of them. So we need all these solutions in our answer. So I'm going to put up here where I'm writing my solutions ... by which I mean and so on. There are more answers than just these 2. There are infinite many. So I need to find a better way of writing these or I'll be here forever. So what I do is I say that x is equal to 2 pi over 3 plus 2k pi. Now k here, what I'm saying is k is any whole number, negative or positive, so it could be 1, 2, 3, or -1, -2, -3, or it could be 0. So I'm saying you add or subtract any multiple of 2 pi onto 2 pi over 3 and you get a solution. And if k was 0, we just get 2 pi over 3, so we get that solution too. Similarly, we can add or subtract any multiple of 2 pi to 4 pi over 3 to get solutions. So we found each solution in the principal range 0 to 2 pi, and then we just say we can add or subtract any multiple of 2 pi to those solutions to get more solutions. And we say that exactly like this, and we have to finish our answer by specifying what we mean by k, because so far it's not actually defined. So someone reading this wouldn't know what k was. So I'm going to say k is in z, where z is the way you represent the integers. So the whole numbers, 0, 1 and minus 1, 2 and minus 2, 3 and minus 3, and so on forever. These are the integers. We're saying that k can be an integer. So this symbol here means is contained within. So k is contained within the integers. So it looks a bit complicated, but hopefully as you practice you'll use this notation more and more. So we're saying that there are an infinite number of solutions, and this is just the way we say it. And that is our final answer.